Hi everyone, welcome back to my Numbers in series. In this video, we're doing a very special kind of question where they give you an expression in terms of x, and they tell you what it's equal to, and then they ask you to evaluate another expression. But the key to these problems is that you're not supposed to solve for x, because solving for x is generally just going to lead you down a harder path than the right one. So let's see an example, right? 5x plus 1 equals 17, 10x plus 3 equals what? Well, of course, with these questions, we can solve for x, right? So let's do that. Let's solve for x. We have 5x, then, if we subtract 1 from both sides, equals 16. So then if we divide both sides by 5, we'll get x equals 16 over 5, or 3.2. Then, any way you plug it in here, you're going to get 10x equals 32, plus 3 equals 35. But that kind of took a long time, right? Even if you're capable of doing this much faster than I did it, I would argue that doing this still takes much more time than what I'm about to show you, because you don't have to solve for x, as I said, right? The most important thing to notice is that we have 5x and 10x. We want to get those x's to line up, right? If anything else happens with 1, if we have a plus 1 that we want to turn into a plus 2, we know how to do that, right? If we have a plus 10 that we want to turn into a minus 8, we know how to do that. We just have to add and subtract something. The most important thing is to get the x's to line up, because we don't know what x is. So how do we turn 5x into 10x? Well, all we have to do is multiply by 2, right? So let's take this equation and multiply both sides by 2. Then we would get 10x plus 2 equals 34. But we don't want 10x plus 2, we want 10x plus 3. But how do we get from 10x plus 2 to 10x plus 3? Well, it's really easy, just add 1. So we have 10x plus 3 equals 35. And that we can write in. So notice that the hardest thing we had to do here was multiply by 2 and then add 1, whereas here we would have to get into fractions, right? And fractions are not always nice. And I would rather multiply by whole numbers and add with whole numbers than have to multiply, solve for here and then multiply another fraction over here, right? For example, 6x minus 2 equals 32, solve for 3x minus 3. This is a pretty similar question, and I'll just show the fractional approach right now, which I would not again recommend, because you get 6x equals 34, and then x equals 17 over 3. So then we have 3x equals 17, so 17 minus 3 equals 14. So once again, you can do this, but I do not recommend it, because once again, instead of doing all of this, you can just notice that we have 6x, we want 3x. So to go from 6 to 3, we divide by 2. So then we would do 3x minus 1 equals 16. Okay, now we have 3x minus 1. We want to get to 3x minus 3. Okay, how can we do that? Well, just subtract 2 more, right? If we want to go from minus 1 to minus 3, we have to subtract 2 more. So it's 16 minus 2 equals 14, and that's our answer. And if this seemed a little bit too easy for you, you could possibly be thinking, okay, well, I could have just done the fractional approach, right? That would only cost me, 1 more second. But in number sense, 1 second really, really matters. I've had times where I missed a leaderboard spot because I didn't get to write down the answer for the question. I knew the answer for the question in my head, but I didn't have that 1 more second to, fully get it and write out my answer. And that cost me my placing. And so, it's definitely just important to optimize any way you can. But there is kind of another way to do things, right? 4x plus 7 equals 26. Now, this isn't my personal favorite way to do this. It's a small alteration from the technique we've been talking about. Some people find it easier. I personally don't, but if you do find it easier, you can do this. 4x plus 7 equals 26. So we can solve for 4x, subtract 7 from both sides, 4x equals 19. Now, what some people do here is just keep this. 4x equals 19, and then they multiply by 2 on both sides and turn it into, 8x equals 38. And then they subtract 4 and they get 34. Now, it looks very, very similar what I just did to what I did over here, but the difference here is that we have to do one more operation, okay? We have to subtract this and then do something else. But that is the difference. That one more operation, once again, can cost you some time. And so this is why this is not my favorite technique, but if it helps you think of it and understand it better, you can definitely do this. It might seem like I'm nitpicking for techniques here, but this is definitely important in my opinion. So, of course, instead of doing solving for 4x, we could just multiply this by 2. And then we would get 8x plus 14 equals 52. Now, to get from plus 14 to minus 4, we have to subtract 18. So 52 minus 18 is again 34. So really, I personally don't find this technique easier, but if you do, absolutely you can use this. Because if you think about it, this technique is basically like solving for the fraction without actually solving for the fraction. If you were to solve for x, you would have to divide this by 4 and then multiply it by 8. Whereas here you can just multiply it by 2 and then be done with it, right? But of course, that is not the only kind of question. And whereas here it is possible to solve for x and substitute that in, here I would not recommend it at all. Okay, do not try to solve for x in these problems. Because here, x is not a nice number. And even if you know your log properties, which I bet some of you do, it's not very helpful here at all. Do not solve for x. Instead, we're going to have to, again, solve indirectly. So how can we get from 3 to the power of x plus 1 to 9 to the power of x minus 1? Well, the important thing to note here is that 9 is 3 squared, right? So 9 to the power of x minus 1, what that really is 3 squared to the power of x minus 1. And you can also think of this, in kind of two ways. Think of it as either 3 to the power of 2x minus 2. Or you can think of it as 3 to the power of x minus 1, then squared. These are, of course, the same expression, equivalent expressions, but the way you do the problem is going to vary depending on these. Here's what I mean. If I want to turn 3 to the power of x plus 1 into 3 to the power of, 2x something something, what I should do is square it, right? So if I square both sides here, what I get is 3 to the power of 2x plus 2 equals 1296. And here is the hard part. I know some of you may not have 36 squared memorized, but I would definitely recommend that you do. This is not a super uncommon number at all. 1296 is actually a pretty common number because it's divisible by lots of 2's and 3's. And so here, we have to then turn 3 to the power of 2x plus 2 into 3 to the power of 2x minus 2. In other words, we have to make the exponent 4 less. We have to subtract 4 from the exponent. And what is subtracting an exponent? That's dividing. We have to divide it by 3 to the power 4, right? That would subtract 4 from the exponent over 3 to the 4th. And so here you would have to do again, what is, 1296 divided by 81. And this is, not a super nice number. The answer would be 16. So you'd have 3 to the power of 2x minus 2 equals 16. But I absolutely understand if this is not good for you. And that is why we can also choose to express it as 3 to the power of x minus 1 and then squared. And this, to me, is better. Because instead of, squaring this right away, we can make it smaller and then square, right? Let me show you what happens when you have this instead. 3 to the power of x minus 1, well, to get from x plus 1 to x minus 1, again, we have to decrease the exponent by 2. We have to subtract 2 from the exponent. And that is equivalent to dividing by 3 squared. So if I divide both sides by 3 squared, what I get is 3 to the power of x minus 1 equals 36 divided by 9, which is 4. And then this is very, very easy. What's 4 squared? Of course, it's 16. So here, kind of like over here, it's about finding the simplest way to get to the expression. You don't want to necessarily mindlessly start squaring. Unless you're good at squares and you're good at these operations in your head, you can feel free to do this, but I wouldn't recommend it because I really appreciate when I can simplify it first and then the rest of it is very easy, right? Would you rather do 36 squared and then divide it by 3 to the power 4, or do 36 divided by 3 squared and then square that? I would definitely rather do the second one. Now similarly here, right? 2 to the power of x plus 2 equals 100. What is 4 to the power of x? Again, we have two ways to kind of think about this. We can either do just square this outright and then deal with the constant term later, which is kind of what I recommend here. I recommend it here, but I don't recommend it here. Or we can get it in a nicer position first and then see if one simple operation will bring us to the end. Let me write out those two. So the first option is to go from a 2 to the power of x plus 2 to 2 to the power of 2x plus 4 to 2 to the power of 2x, which is equal to 4 to the x. That's the important thing to recognize, by the way. 4 to the x equals 2 to the 2x. Or we can go from 2 to the power of x plus 2 to 2 to the power of x, and then 2 to the power of 2x. And the way you do these kind of depends on, I get it, in the test, it's in the heat of the moment. You have to decide what you're going to do very fast. And sometimes you find yourself down too far on a path that isn't super great, but also it's too late to turn back. I've done that before as well. So don't feel bad, but it is good to train a skill that is like, oh, I can see this and I recognize what path is going to be the easiest, right? And of course that does come with practice, but it also comes with just actively thinking about what you're doing, metacognition. So, in the actual execution, they're going to be pretty similar. So let's just do it. 2 to the power of x plus 2. Now, of course, I want to turn it into 2 to the power of 2x something something, and I'll deal with the something something later. So to get it to 2 to the power of 2x plus 4, I'll square it. So 100 squared is going to be 10,000. So I have 2 to the power of 2x plus 4 equals 10,000. But I want this to be equal to 2 to the power of 2x. So I'll divide both sides by 2 to the power of 4. And once again, this is the bad part. You have to do 10,000 divided by 16. I know that is not something that people, regularly have memorized at all. But if you do have this memorized for some reason, the answer is 625. But this is not a good way in my opinion, because I would rather simplify it and then square it, right? 2 to the power of x plus 2, let's turn that into 2 to the power of x first. If I turn it into 2 to the power of x, then I will divide both sides by 2 squared, right? Subtract 2 from the exponent, divide both sides by 4, and I get 2 to the power of x equals 25. And that is nice, because all I have to do now is square it. And 25 squared is 625. And once again, notice in these last two problems, there is no way you can solve for an actual value of x. If you know, about exponents and logs already, you might be able to get an expression for x, right? X equals log base 2 of 25, but that's not going to get you anywhere useful. And if it is going to get you anywhere useful, it's going to be much more hassle than just doing this. So I've talked a lot today, but understand that this video is about solving problems without solving for x, right? Our goal is to manipulate the problem in a way such that we never have to actually solve for x, because often x is going to be some non-nice expression, and sometimes it's going to be a very, very not nice expression. So the goal is essentially to figure out, what do I have to multiply or divide or exponentiate by in order to get this equation into something that looks similar to my answer, and then how can I turn it into my answer? So that is going to be it for today. Thank you guys so much for watching, and I'll see you next time.